Okay, welcome to the sequel, even more gruesome than the first. So, I realize it's going to take a little bit to get used to this, but just study it. We'll spend a little time when we have our meetings. But it's a lot of the same on how we solve these. So we ended up at 4. Or sorry, -4 and 2. So we have our resultant vector ends right there. So now, if we solve for all of these magnitudes here, and we solve for all of the angles. So here we have 68.1, an angle of 68.1 is this triangle. Now, notice that x and y have only given you 2 coordinates, which is the opposite and adjacent. So this sort of ties into the solve total triangle exercises. We're just solving for these guys and then adding it to the angle. So it's just a matter of understanding which is opposite. That's usually the most challenging part. So once you get past that, we ended up with vector 1 has rotated from here, from 0, it has rotated all the way around to here. So it has rotated from x all the way around to there. So that's at 180 degrees, we can just add this little bit in here. So 180 plus the 68 gives us so now it has rotated 248.1 degrees. And we'll do the same thing for each one of them. So the v vector, for example, now we're sitting there, this is the x, this is 270. So it has rotated now from x all the way around past 270, and it's approaching 360. So we have here, this is 90, 270, this is our x at 360, or 0. So we have 6 and 1. Now this is -1, but I'm just expressing it as a triangle would be, just with a number, because it is just 1 unit. So you have 6, 1 here, so that means that the 6 becomes the opposite. So tan 6 to 1 gives us 6. Tells us that this angle in here is about 80.5 degrees. We want to track down the hypotenuse, use our sine, gives us 6.08. So we have a magnitude of 6.08 and 80.5 degrees. But it's rotated past 270, 80 more degrees. So here we have a magnitude of 6.08. And 270 plus the 80 it's rotated, so we're looking at 350.5 degrees. We do the same thing here with these next two, with this next one here, which is our right here. So we have 11 and 1, what we brought down here, 11 over 1. So we have an angle right in here, 1 over 11, 0.09, gives us 5.19 degrees, and gives us 11.05 as a magnitude. And then just to finish it off here, we have our final vector, the z vector, 3 and 9, 3 over, and if we look here, right, this is 90 degrees. This vector has not rotated past 90 degrees here. So we got this the x-axis, it's rotated this far, but not past 90. So we have here 3 and 9, tan, 71.5 degrees is what this is, 9.49 as a magnitude. So here we don't have to express anything. We have our 3 and 9, 71.5. It hasn't gone past 90, 80. 70, whatever. So it just is as it is. And our resultant vector, just to finish it off, gives us 4.47 with an angle of 90 plus 63.4. And again, we found the resultant the same way. It's sitting at 4 and 2. And we could add that in like this here. So we have 2 and 4. And it has rotated past 90, 63.4 degrees. So we add that up and we end up with 153.4. So if you add this up, put your calculator into polar. 5.38 angle 248.1, 6.08 angle 350.5, 11.05 angle 185.9, 9.49 angle 71.5 equals, it'll bring up 4.47, hit your angle, 153.4. And that should all add up for you. So that is the beginning of our vector addition. And that's it.